The market potential for quantum computing isn't just in the billions, it's believed that it will be in the trillions. In the next 1 to 2 years, we believe that we will start to see the first practical applications of quantum computing. And you might say, well, I'll just wait until then. I'll wait until I see the headlines of this before I start getting into it. But the reason that doesn't work is because it takes time to write the software, to understand how this works, to understand how it affects your industry. And so it's not simply a matter of turning on a dime once you see the headlines about quantum being relevant. And so that's why it's absolutely essential right now to start investing in this for your organization. I'm Dr. Mark Jackson. I studied physics and math at Duke University for my undergraduate studies. For graduate school, I got my PhD at Columbia University in superstring theory and cosmology. I then did several postdocs and teaching positions around the world, including at Singularity University. About 7 years ago, I was hired by a small British startup called Cambridge Quantum Computing. They were one of the very first quantum computing startups. We focused on quantum software, and we had a partnership with Honeywell's quantum hardware team, which went so well that about 3 years ago, we merged. Honeywell spun out their hardware team, and so we formed a new company called Quantinuum. My role at Quantinuum is Senior Quantum Evangelist. So this means that it's my job to create awareness and excitement about quantum computing. As a former physics professor, this is my absolute dream job because I get to communicate why quantum computing is so important, what it is, why it's different from conventional computing, and how it will affect your industry. Quantum computing is not just a faster type of computer, it's a completely different type of computation. No, the primary difference between a quantum computer and a normal computer is that whereas a normal computer is based on bits, which are 0 or 1, a quantum computer is based on a quantum bit or a qubit, which can be 0 and 1 at the same time. And the reason that this is important is because this means one qubit would represent 2 different possible solutions to a problem. 2 qubits would represent 4 different possible solutions to a problem. 3 qubits would represent 8 possible solutions to a problem, and so forth. And so you see, you get this exponential scaling of possible solutions that a quantum computer would consider. There are some problems that can take advantage of this, and it's vastly faster to do this on a quantum computer than with a normal computer. The idea for this started about 40 years ago, and it was only about 10 years ago that there were some breakthroughs that made people realize this might actually work. And so the commercial quantum computing sector only started about 10 years ago, and it's actually only now, this year, that we're starting to see quantum computers overtake conventional computers in some tasks. And so this is why it's absolutely essential that executives and especially tech leaders understand what quantum computing is and how it can help them. So one might ask, what are the applications that you would use a quantum computer for? So one thing that quantum computers are very good at is chemistry. And by that, I mean being able to do material science calculations, trying to simulate molecules and understand how they'll behave. Another application is doing personalized medicine, because it takes about 10 years and $1 billion for a pharmaceutical company to bring a drug to market. And with a quantum computer, we think that we could speed this up and make it much more efficient. There's also the aspect of cybersecurity. A lot of people have probably seen headlines about how quantum computing is relevant to hacking or cybersecurity. The reason that this is of concern today is because now that quantum is becoming pretty powerful, a lot of governments and communications companies are very concerned about this. This is a very real threat. And a lot of companies, including Apple and Zoom, have recently, just in the past few months, started to upgrade their cybersecurity to protect against quantum hacking. What's lesser known, though, is that quantum can also be used to protect communication. And so I'll discuss that in some of my session as well. The market potential for quantum computing isn't just in the billions. It's believed that it will be in the trillions. For all the areas that I've mentioned earlier, in the pharmaceutical sector, in material science, in machine learning and AI, and cybersecurity, there are so many ways that quantum computing will be able to provide value. Unfortunately, it's very expensive to build a quantum computer right now. And so it's only really very developed countries that are investing in this. There's North America, there's Europe. China is very heavily focused in investing in quantum, especially for communication. And so right now, unfortunately, it is still only in the hands of very developed countries. We hope that will change quickly. The price of quantum computing is coming down. A lot of people have access to it over the cloud. There's much more education about quantum being done right now. And so hopefully there will be more of a democratization of quantum soon. By far the biggest misconception that I come across is that people think that quantum computing might be relevant in 20 years. And the reason that this is incorrect is because they've probably heard about quantum for so long, and the joke was that it was always 10 years away, and so they feel confident that this is just another iteration of that. The reason that that's no longer true is because it was about 10 years ago that there were some breakthroughs and people realized this might actually work. After that, and the commercial quantum sector started, there's been enormous progress. Many of you are probably familiar with Moore's Law, which has shown that normal computers have doubled in performance every 18 months or so. Quantum has increased its performance by about a factor of 10 every year. And so even though just a few years ago it wasn't very powerful, it is now. It's quickly starting to overtake conventional computing in some areas. And so that's why we believe that we will start to see the first practical applications just in the next 1 to 2 years. The organizations which will take most advantage of this are those who have already begun. And so it really is essential that if you're not already investing in quantum, that you start developing expertise and investing in this now. I'm looking forward to seeing you at the OpenExo Exponential Executive Program.